everyone. This is Ben with Math Moments, and here we have a calculus video with definition of the derivative. So we're going to use this definition using the limit as h approaches 0 of f of x plus h minus f of x all over h, and that's to find f prime of x. So that's the first derivative of this function, f of x equals square root of x. So I'm going to try to find a derivative of the square root function. So let's get started. So we're just going to apply this definition. We got limit h approaches 0. So f of x plus h. So we're going to replace x with x plus h. So that's going to give us square root of x plus h. And then we're going to have minus f of x, which is square root of x. And then that's all over h. So the key thing here is as h approaches 0, we need to try to figure out a way to get this h in the denominator to cancel out. So one way to do this is to multiply the top and the bottom, the numerator and denominator, by what's called the conjugate of this expression here. The square root of x plus h minus square root of x. So when we do that, our next step will be limit as h approaches 0. We got square root x plus h minus square root of x all over h. And we're just going to multiply the top and the bottom by the conjugate. So that's going to be the exact same terms, be square root of x plus h, and then we have square root of x here. The only difference is we're going to change the sign. It's going to be the opposite of minus. Subtraction will be addition, so we have plus. So you can kind of see this is like a difference of two squares. All right, because that's how you factor a difference of two squares. So just reviewing that real quick here at the top here. A squared minus b squared equals a plus b times a minus b. So you can see that your a is like your x plus h, square root of x plus h in this case, and your b is your square root of x. And so you have the exact same terms, you just have different signs here. And then we're going to multiply this exact same term, square root of x plus h, and then plus square root of x. On the bottom as well. So let's see what happens here when we do that. Just using the FOIL method, right? First, and then outside, and inside, and then we have our last. So square root of x plus h times square root of x plus h, that's going to give us, well, we have to write the limit here first. Let's do that. H approaches 0, so that's going to be x plus h. If you can see this next term, the outside term, square root of x plus h times square root of x, and minus x, or minus square root of x in this case, times square root of x plus h. You can see these are exact same terms, but they're opposite signs. So those are going to cancel out for us, which is great. And then all we're left with is the last terms, right? So negative square root of x times positive square root of x. Positive square root of x. So that's just going to give us a minus square root of x squared, which is just x. And that's all over h times square root of x plus h. And then we have our plus square root of x on the bottom. And this is going to help us out a lot here, right? Because these x's are going to cancel out. And this h here is only left on the top. So limit h approaches 0. And you can see that doing a little bit of work here, we have this h on top and this h on the bottom. So those are going to cancel out. And that just gives us 1 here in the numerator. So that's just going to be 1 all over square root of x plus h plus square root of x. And now we can substitute this value h equals 0 into our expression. So when we do that, we're going to get 1 over square root of x plus h is 0 in this case, plus square root of x. And then of course that's going to equal square root of x plus 0 is just square root of x, so that's 1 over square root of x plus square root of x. So that equals 1 over 2 times the square root of x. Right, so that is our final answer. If we want to express this in terms of exponent, we do know that the square root of x is x to the 1/2. All right, so we could rewrite this as 1 over 2 x to the 1/2 power. And this is the same thing as 1/2. And if we bring this x to the 1/2 into the top, the numerator, we made that exponent negative, right? We changed the sign of the power. So that'll be 1/2 x to the minus 1/2. So that's another way you can express that derivative for f of x. So I hope this video was helpful in using the definition of the derivative. I know it's quite a few steps here, a little bit of a process, but the key thing here is to just make sure you plug in everything properly, your f of x plus h, then minus your f of x all over your h. That's called the difference quotient, because we're taking a difference here on top, and then we have divided by h, so we're using quotient. So we're dividing something and taking the difference up top of those two terms. And that helps us find the slope of the tangent line of this function f of x equals square root of x, which is x to the 1/2. So we can see that f of x equals x to 1/2. The derivative of that, the slope of the tangent line, is 1/2 x to the minus 1/2. And you will learn something, in derivatives in calculus called the power rule, and you'll learn what that is, and you'll understand why I decided to do it this way, to express it this way. and it'll make a lot more sense once you learn the power rules. So for now, this is just using the definition, and I hope this was helpful. Just takes practice. And again, this has been with Math Moments today, and I hope you have a great day and take care.